Here are the solutions with points to this free response question, again from 2018. So for part A, we're given this differential equation, and then we're given the slope field for this differential equation. We want to sketch the solution curve that passes through the point, first through 0, 2. So if you take a look right up here is the point 0, 2. And if you notice, all of the little tangent segments here look like they're equal to 0 or horizontal. So we would just have a horizontal line going through there, so that would be 1 point. Then we also need to sketch one going through 1, 0. So if we kind of started from this side, it looks like we're kind of coming down. Then we would follow this a little bit, and then right here's another horizontal, and then we start to go right back up. So there would be the other curve. So 2 points here. And again, they make a point to indicate that curves must go through the indicated points, follow the given slope lines, and extend to the boundary of the slope field. So 2 points for that. All right, question B. Let y equals f of x be the particular solution to the given differential equation with the initial condition f of 1 is equal to 0. Write an equation for the line tangent to the graph of y equals f of x at x equals 1. Use your equation to approximate f of 0.7. Again, this is a no calculator question, but in order to write an equation of the line, we need the slope of the tangent line, which is equal to dy over dx, which is that equation that we were given above. So that's equal to 1/3 x y minus 2, that quantity squared. And then we also need the point. Well, at x equals 1, y is equal to 0, so we would use the point 1, 0. So I'll write out the work below. So for part B, the slope of our tangent line, which is equal to dy over dx, is equal to 1/3. I'll just write this out showing that we're using this. And then at 1, 0, dy over dx is equal to 1/3 times 1, and that'll just give us times negative 2 squared, which is equal to 4/3. So now we write our equation. So we would have, again, I'm just going to use point slope form, so we would have y minus 0, y minus y1 is equal to our slope, 4/3, times x minus x1. So we could just say y is going to equal 4/3 times the quantity x minus 1. And then we want to approximate f of 0.7. So we would just have 4/3 times 0.7 minus 1. And this would give us 4/3 times a negative 0.3 or 3/10. So we would get negative 4/10 or negative 0.4. So 2 points for this, 1 point for the equation of the tangent line, and 1 point for the approximation. Now for C, this is where we're actually going to solve the differential equation with this initial condition f of 1 is equal to 0. So we want to separate the variables very carefully. So I'm going to divide both sides by the quantity y minus 2 squared. So we'll have dy over this quantity is going to equal 1/3 x dx. Now we want to take the integral of both sides, so clearly show that. I'm going to write this as the quantity y minus 2 to the negative second dy. I'll put the 1/3 out in front times the integral of x dx. Now just because it's in a denominator doesn't mean we use a natural log. We would only do that if our power was 1. So here we just use the power rule for antiderivative. So I'm going to add 1, so this will become y minus 2 to the negative first over negative 1. We'll just save our c to the other side. We'll get 1/3 times x squared over 2 plus c. And I'll rewrite this. This will just become negative 1 over the quantity y minus 2. We'll say 1/6 x squared plus c. Now it's at this point that it's the easiest to use the initial condition that f of 1 is equal to 0. So then that means we'll have, if y is 0, we'll have a 1/2 is going to equal 1/6 times 1 squared plus c. So 1/2 minus 1/6 is 3/6 minus 1/6. We get 2/6 or 1/3. So c is equal to 1/3. And now we'll continue. So we'll get negative 1 over y minus 2 is equal to 1/6 x squared plus 1/3. Just to make it easier, because I am going to need to take the reciprocal, I'm going to write this right side as just one fraction. So we get negative 1 over y minus 2. This will give us x squared we could look at this as 2, 6, so plus 2 all over 6. I could cross multiply or take the reciprocal of both sides here, but that would end up leaving me with negative 6 over x squared plus 2 is equal to y minus 2. Solve for y, so y, I'll just put the 2 first. Y is going to equal 2 and then minus 6 over x squared plus 2. They also make a note that this solution is valid for all real numbers x. So you get 1 point for separation of variables, 2 points for the antiderivatives, 1 point for constant of integration, c, and 1 point for solving for y. Now there could be a couple different equivalences that they should accept for this, but 5 points there, and then we had 2 for each part A and part B. As I always say, keep practicing problems, the free response questions, so make sure you go over this one several more times before Tuesday.